broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. My name's James Craig. I'm the Technical Program Manager of the IEA GHG Program based here in Cheltenham, UK. Today, we have a webinar, CO2 Data Share, which is an exciting initiative co-developed between the University of Illinois in the US, who are behind the Decatur deep formation, saline formation project, and SINTEF and Equinor in Norway. You will hear more about what CO2 Data Share system is shortly. So for those of you not familiar with us, the IEA GHG program is a greenhouse gas R&D, what's now called Technology Collaboration Program. We've been running since 1991, and we now have 36 members, including 16 countries, which all contribute towards the program and support us. Amongst other things, we run webinars, and we also run some R&D projects and various other initiatives, which many of you will be familiar with. We set a strategic direction for the technical program, basically on, carbon capture, utilization, and storage now. We are independent. When we don't define policy, that's up to folk like the IEA in Paris, and we're not technology advocates. That's done by other trade bodies. So we develop mitigation options for carbon capture, and increasingly now looking at the use of CO2, in areas such as enhanced oil recovery and in things like carbonated building products, that kind of thing. Always looking at the development of capture technologies, cost reduction, trying to really pushing the technology along to full-scale industrial operation. And particularly relevant today, the geological side of CO2 storage, of which this project is heavily integrated with. Mentioned we provide our members with policy and independent technical input. Just a quick look there, you can see quite a variety of countries and organizations, which shows the breadth of interest from our members, and we are obviously always keen to express our gratitude to them as they support us and this program. Okay, so today the bulk of the talk will be a series of 4 linked presentations, starting with Greta Tanger from SINTEF. She will give an outline of the project's background, a demonstration of the CO2 Data Share facility by Odd Anderson from SINTEF, followed then by Philip Ringrose from Equinor on the Sleipner benchmark model, finishing off with 4D seismic data discussion for Anna Kara-Furia from Equinor. I apologize in advance for my pronunciation there. And we will have an opportunity for discussion and questions following those 4 linked presentations. So just very quickly, Greta Tanger is a senior scientist with SINTEF. She has an engineering background and is a case leader and member of the management team of the Norwegian CCS Research Centre, and is heavily involved in, is in fact the project manager for CO2 Data Share. Odd Anderson, also from SINTEF, background in mathematics and cybernetics, strong mathematical modeling background, and he's been heavily involved in the software development of this and other projects. Philip Ringrose works for Equinor, leads the carbon storage side of that company's initiative in this area, has a strong geological background, and certainly contributes widely to many of our initiatives. And finally, Anna Karafura, also is a geophysicist, has a lot of background in rock physics, time-lapse monitoring, seismic interpretation, which many of you know is one of the key monitoring technologies for CO2 injection. And just before we start off with the CO2 data share, just a quick reminder that one of our main core activities is the GHG conference, which this year in October is in Abu Dhabi. So I would just draw your attention to that. Registration will be open end of March. So with I will now hand over to Greta for the start of the CO2 data share.
Okay, thank you. Thank you, Jane, for that nice introduction. Do you see my screen properly now?
Yes, we do. I don't know if it's filling the whole page, Greta. Can you just check it on full slide?
Yeah. Is it filling the whole screen?
Yeah, I think so. So just carry on, Greta.
Yeah, I will start. Thank you so much. I will start by presenting the CO2 Storage Data Consortium and also talk about the CO2 Data Share project. This CO2 Storage Data Consortium is actually an open international network for sharing data and knowledge between international actors. And it was initiated, as you mentioned, James, by Equinor, University of Illinois, and SINTEF, and yourself in 2016, and has received financial support from Gassnova in Norway and also U.S. Department of Energy. And this initiative is started to try to overcome a lack of data as a barrier for developing new knowledge and technology related to CO2 storage, and therefore also related to CCS deployment. And also we think that this initiative is relevant for building confidence in CO2 storage and also as CCS as a measure to reduce the emissions of CO2. And the first data we are now sharing is from the Sleipner project that many of you know well. The Sleipner project has been storing CO2 ever since 1996, now that we will talk more about the Sleipner data, but now that we have this solution ready, we are looking forward, and we are discussing how we can operate this consortium beyond the 3 years that we have received funding for. So we are now welcoming other countries also to work with us in this consortium. I also would like to say a little bit about the CO2 Data Share project, and that has been the main activity of the consortium for the last couple of years. We have our funding from the Climate Research Program in Norway and U.S. Department of Energy. And for the last couple of years, we have been building a digital platform for sharing CO2 storage data sets. And that is to improve the understanding, to reduce costs, and also minimize uncertainties related to CO2 storage. And CO2 Data Share now offers a simple and standard and low-cost solution for making data available to researchers all over the world. And this is an open access solution, so the data are available to all. The portal was launched February this year, and the two first data sets were shared. And from this launch, we see that some data packages has been downloaded more than 50 times already. So we see that people are actually accessing and downloading the data that are made available. And through this portal, we think that researchers can get access to the best available data and use it in the research to advance the knowledge and build the capacity. So they can use it for refining models, developing new methods, and also to drive commercialization of technology related to CO2 storage. And by comparing results and collaborating, researchers also contribute to reducing the uncertainty related to the technology. A little bit about the data sets. Our main criteria for choosing the data sets to be shared is the quality of the data and also the relevance of the data to the CCS research and development work. So it's not the size or the cost of producing the data set that is deciding which data to share. And the data that are made available now are the new generation of the Sleipner datasets, the 2019 benchmark model, and also the 4D seismics. And we will hear more about them in this webinar. But we also have an ambition to expand to include other datasets, both from ongoing projects, but also in emerging projects that will take place in the years to come. Data from the CO2, the Sleipner CO2 project has been shared before, and I think that illustrates very much the value of sharing data. Previously, shared data sets have been used by more than 40 institutions for research, and a large number of scientific publications are based on these data. So we hope that our new portal can have a similar effect, and that data owners and also the CCS community can get insights and new knowledge from having researchers to use this new data. Yeah, so when it comes to the portal itself, as I mentioned, we focus quality rather than quantity in this portal, and therefore documentation is essential. So each data set will have an individual and customized web page for presentation. That is what we call a landing page. So this landing page will give an overview of the data, but also more detailed descriptions of the data sets, and may include pictures and diagrams and tables, and also refer to relevant publications. Odd Andersen will later in this webinar go a little bit more into the details of the portal, and also show you how the datasets documentation. The basic structure of this portal is illustrated in this picture. We have, of course, the data providers, the owners of the data that are willing to share the data from CO2 storage projects. And we have the data users using this for developing new knowledge, and they can be located all around the globe. When we have built this portal, we have chosen to use existing national infrastructure and services, and also open source software for the solution. The repository that we are using is owned by Uninet Sigma 2, which is a non-profit company in Norway and manages the national infrastructure for computational science in Norway. And that repository is combined with a portal that has been developed using an open source software called CCAN. So during these 2 last years, we have specified and implemented this portal, and it's now complete and available for use. Yeah, and it's our strong opinion that such services, sharing of data, will create opportunities for advancing knowledge. And we also see that these opportunities can be stimulated, and it can be illustrated by this example. CLIMIT is a national program for funding research and development of CCS technologies in Norway. And to promote research and innovation from the data that we are now sharing, the CLIMIT has announced the call on a benchmark study on CO2 plume dynamics using the new Sleipner benchmark model, and thereby utilizing the capabilities of CO2 Data Share portal. And 4 different studies are now awarded funding and will take place this year. So we hope that we can see the same effect as we have seen for previous data sets from Sleipner, so that learnings from researchers can be produced and delivered to the CCS community, but also back to the owners of the data sets. Yeah, so this kind of summarizes what we see as main benefits of having a portal for sharing data sets on CO2 storage. First, we have the owners of the data. They will see a reduced cost of preparing the data and sharing it. Also, we see that data owners can get new insights from researchers using this data and developing new models, new methods, and new knowledge from the data. Also, data owners can receive more visibility within the CCS area, including citations in scientific publications. For the data users, these data are open access, so they are easy to discover, and they easily can have access to quality data. And by a thorough documentation of the data, we ensure that the data is understood and can be used correctly. And having access to a set of data will give a common ground for international collaboration and comparison. For the society at large, we see that having access to data all over the globe, it's possible to reproduce research to ensure quality. It can also boost the research related to CO2 storage. And as we are organized now, national funding agencies are members of the board and therefore also can influence the strategic direction of this consortium. So to maintain the operation and the maintenance of this CO2 data share portal, we are now working on alternative models for funding and also international funding opportunities, so that we are able to expand this consortium to countries besides the US and Norway. That was about what I have planned to say in this part of the presentation. I will then give the word to Odd Andersen from SINTEF, if you would like to request control.
Okay, so can you all hear me?
Yes.
Yes. Okay, so my name is Odd Andersen, and I have worked a bit on the technical side with implementing and setting up the digital portal. And I will give a brief overview of how it works and what you can do with it. Let me see. So this is the URL, co2datashare.org. If you try to Google CO2 data share, you might not get it as your first choice just yet. It has not been up very long, but it's climbing up in the search ranking. So once you go there, you will be greeted by this page, the front page of the portal. And here you have the ability to go and search for data sets, or to look at the organizations that have contributed data. So key characteristics of the portal. is that they disseminate what we call reference datasets that are uploaded and prepared and uploaded by the CSDC consortium and the CO2 Data Share project in collaboration with the actual data owners. Reference datasets should be high-quality datasets that are useful for a wider audience and that are related to actual projects on geological CO2 storage. And it's important that before the data is shared on the portal, that we verify that that is adequately documented and has been quality checked, and that the data is logically organized. And not the least that the license rights have been fully sorted out, so that it should be very easy to just download the data and know exactly what you can do with it. Reference datasets are also organized into data components. So a dataset can contain several components where each component consists of more or less homogeneous types of data. So for instance, the Sleipner dataset contains a simulation grid. That's one component, and then there's well logs, which are bundled into another component, and so on. Datasets might be open, which means that they can be freely downloaded. There is also a possibility to restrict access, which means that the dataset will still be presented online with all its metadata and the presentational page, but that in order to actually download the data, you have to get approval by the owning organization. And finally, you can also publish datasets that are under embargo, so that you will still see the information about the data, but the data will only be available after a set date. In the original software, there is also a user login and API functionality. For the moment, we have disabled the user login and API in order to keep things as simple as possible. But it's likely that user login will appear in the future. In particular, if we start hosting restricted data, where you have to actually get individual or access on an individual basis. That is not the preferred access level, but we foresee that it might be possible. So let me try to switch there. Okay. So each dataset is presented by its own presentational page, which we refer to as a landing page. There are several components of this page. So on the upper left side here, you see that we indicate the geographical location of the data. And on the right, there is an introduction to the dataset, which is HTML, and which might contain tables and links and pictures and what whatever you want in order to give a presentation of the dataset itself. On the left column, you also see the different dataset components. So in this case, which is a Sleipner benchmark model, you can see that there's the grid, the feeders, the well data, and so on. So you can select the components that you want and then download them down on the bottom here. Further down on the page, you will see a link to the owning organization. In this case, it's Equinor. There will be a link to the license that you have to agree on before downloading the data. And if you go all the way down to the page, you see additional metadata here, further references to further reading. And among the additional metadata, you can see also that there is a digital object identifier at the very bottom here, which means that you can use this as a citation. So you can cite the data set. Also, there is possibility of assigning metadata to individual dataset components. So if you click on a component, you can also see its own presentational page. Here is for the grid of the Sleipner reference model. It's not all that comprehensive, but you have some additional information about the grid here on the bottom right. And you can see here, for instance, that it has been categorized as data category 331, reservoir simulation models and associated data. So this is a kind of classification system that we have introduced in order to make it easier to search for specific types of data. Because, of course, data related to CO2 storage may be of many different kinds, and you might be only interested in specific types of data, for instance, core sample data or seismic or so on. So I try to make some kind of classification that where you can filter to search for the kind of data that you want. Of course, right now with only 2 data sets, this is of limited use, but it can be useful and also further extended in the future. Each of the contributing organizations also get their own presentational page on the portal, where we can put key information about the company, and also if the company is interested, they can put up contact persons that you can see here. For Sintef, we have put up Grete and myself. And a few words on finding datasets. Again, with 2 datasets, this is a little bit not necessary yet, but in the functionality is there to do free text search in this search dataset field up here. You can do a facet filter search by choosing, for instance, which data categories you're interested in, what data formats, and so on. That is on this left side. You can do a geographical search by selecting a region up in this map on the upper left side and search for datasets associated with that region. Or you can search just by browsing datasets and see how they link to each other, and so on. When you download a dataset component, what you get is an archive file, typically a zip file. And in order to assure data integrity, we have applied the Bagit system. So that means that all the files are contained in this data folder inside the zip file. And these additional files contain information about what files should be there, and also provides hashes so that you can verify that the actual data have not been changed in any way. So this is a way to verify the content integrity. And that concludes my presentation. So I will let Philip and Anne-Kari have the next word.
Sure.
Thank you.
Thank you, Odd. So yeah, Philip Ringrose here from Equinor. Hopefully everybody can still hear and see the same presentation. So what we will do now, myself followed by Anne-Kari, we'll just say a little bit about the 2 data sets that are in the portal right now, because people might be eager to see them. But everything that we say is actually in the metadata that Odd has just described. So this is just a short introduction. We built a new reference model for the Sleipner CO2 storage site last year, 2019. That model was built by Andrea Santi, so give her full credit for that, with support from Anne-Kari and myself. If you're involved in building geological models of the subsurface, you'll know that it's not straightforward. Nothing is precise. So to make a reference model, we had to do a lot of depth conversion from the seismic time-lapse data, matching to wells, and we used an uncertainty modeling workflow called HUM, and we document how that was done to get a reasonably good assumption on the depth conversion from the top to the bottom of the Utsira system. So it's a model based on seismic data calibrated to wells. It's a very fine grid model because we intend it to be used for reservoir simulation to understand the CO2 migration process. So the reference grid is 50 by 50 meters in X and Y, variable in Z down to just a few meters. and that's close to the seismic resolution. Basic petrophysical parameters are included, but they're actually constant per layer at this stage in the reference model. So the depth surfaces look a little bit like that. There are 9 main layers in the sandstone unit. As you go upwards, there's a slightly more shale, and there's a thick shale towards the top, and then the overlying cap rock is also digitized as a thick shale layer, and the cap rock goes beyond that. And in the dotted line, you can see the well trajectory, so the well path to the point at the bottom of the Zero formation where the CO2 injection is actually occurring, and you see a 3D model to the bottom right. And then, we focused a lot on the shales. If anyone has looked at the Sleipner CO2 injection project, you'll know that what happens is that the CO2 gets dispersed under a number of shales, and then at some point finds its way up through a shale to the next layer. So all of the 9 layers have some CO2, but it varies according to layer, and we use time-lapse seismic to try and monitor that distribution. So what we try to do is focus on modeling of the shales because they control the migration, and we've got a lot of detail and a thin shale for each one. There's this important sand wedge at the top with a thick shale layer as well. So altogether, there's 18 model zones, and when you add that all up to the way we've gridded it, you end up with 2 million grid cells on a grid format that can be exported to any reservoir simulation package called the corner point geometry format. And so the main intention of it, of course, is for people to look at dynamic flow within this system, but you may have other uses for the grid, of course. And then the last slide I've just got is on the properties. The sandstone is very homogeneous. So the red is all high porosity permeability sandstone. And at this stage, we've said that the sandstones are constant properties per layer. And the shales are more important because they control that vertical migration. And we've also digitized in where we know or think there are breach points in the shales so that you can track how the CO2 moves vertically through the system. So that's a really brief explanation that there's an explanation in the metadata as to how this geological model was built, the supporting well data, the supporting seismic data, but it means that a user can start working on how CO2 moves in the subsurface quite quickly with this model. But then as soon as they start working with it, they will encounter some of the challenges in trying to get that behavior correctly predicted. So it's not an easy thing to match this data set. And that's kind of the point. We want different researchers to look at it and explore it and try and understand the dynamics of CO2 flow behavior in the subsurface. So I think that's enough on the geological reservoir simulation grid. So now Anna-Kari will describe some more of the seismic.
Yes, thank you, Philip. As Philip described, we have made a benchmark model, a reservoir simulation model, and a lot of the way that we have constructed that is actually based on our seismic time-lapse observations. It shows very well here on the right-hand slide, where we see a seismic image pre-injection and compared to the same image after injection. And we see very clearly where the CO2 shows up because it has a large contrast compared to the saline water that was in place previously. I can mention that the 9 layers that someone is taking my mouse.
Yeah.
I can mention that the 9 layers that Philip mentioned, they are not really visible prior to CO2 injection. And that means that there is a large uncertainty related to the actual extent of them. But we have used our knowledge of the time-lapse seismic response to populate it. And that means that they are more trustable, I would say, inside the CO2 plume than outside it. So any forward predictions are more uncertain.
The reason we are operating with 9 layers is that we actually see 9 layers in this time-lapse data. At least at the resolution we have, there might be more layers there, but we can't really see it. What I'll now do is just to summarize the seismic data sets that are available here. To the right, you see a map where I have outlined the released data set. It's 28 approximately square kilometers lateral extent. It covers the main part of the plume. It covers the CO2 injection well that you can see in yellow, and it also covers an exploration well that you see in white there. It only extends down to 2000 milliseconds in time, which corresponds to about 2000 meters. The reason for that is that below there we have the Sleipner Öst or East hydrocarbon field, and we are not releasing data relevant to that. The seismic baseline is from 1994, and we have totally 6 repeated seismic surveys. Note that these repeated seismic surveys actually do have some different acquisition parameters, and that is actually relevant when you are comparing back to the baseline. And that means actually we also have different processing time-lapse vintages. We are releasing 4 offset stacks, the full fold, and then near, mid, and far offset stacks for the time-lapse data. In 2010, we acquired the seismic data with acquisition technology that actually favored bringing out higher frequencies in the data than we had from the old data sets. So we also release a high frequency processing of the 2010 data, and there we can actually also see more higher resolution than what we see in the time-lapse data. And with that, I would just encourage you to use these data. And I will also like to remind you that someone has paid for it. And there is a list here of who contributed both to the acquisition and the processing. So please acknowledge those respective owners when you're publishing findings that are based on any of these data. I think with that, I'll just leave the word to James for the rest of the session or for the questions.
Okay, thank you. Thanks very much for that detailed background. Of course, Sleipner is well known to many people, certainly in the storage field. And we would hope that this whole facility expands and includes new data sets, as you've all alluded to. So the question does arise, if somebody approaches the CO2 Data Share management team, if I can call them that, with a suite of data, 2 questions. One, will it be organized in the way that you have explained for Sleipner? And how will it be managed? How will it be checked and verified? So that's a question for all of you.
Do you want to start, Greta?
Yes, I can start, and then Philip and maybe also Odd could fill in. If we have, I think there is a wide range of type of data that we can foresee that can be shared in this data share portal, and I think that the structuring and how it is represented in the portal will be adjusted to what kind of data it is, and we will have metadata that kind of matches the needs of the data set. So that is one part of it. And then when it comes to quality assurance, and preparing the data. That is something that the project needs to do together with the data owner. And that, for the Sleipner data, that has been quite a long process to work together to prepare and represent the data and make the landing pages for the data sets.
Yeah, if I could add something, Greta, I mean, I think we do want new data sets, but they should be of a certain quality. What we're not expecting is to just dump raw data sets in this facility. It's meant to be, if you like, reference data sets which would be useful to the research community and understandable. So if somebody offers us a data set, we would go through a process of just checking that it's understandable and credible to, you know, normal users, that they understand how to use the data. But I think the experience with the Sleipner data set has taught us what it takes to do that. And Odd may add something, but basically we would need to have developed this metadata to describe it and to test that it downloads successfully and you know, works. And then we would be very happy to say, right, we've got a new data set. So it'd probably take a few months minimum to validate a new data set if it came in.
Also, I mean, presumably there is the potential to expand this to other areas related to CO2 storage. I'm thinking perhaps of environmental data, environmental monitoring data. Do you think that's a possibility?
Yeah, that's definitely relevant. And I know a couple of groups around the world that have collected marine or surface environmental data. So that would be certainly valid, yes.
And we're just getting a question in now.
Is it easier for me to just read it out?
Yes, just read it out.
Okay, there's a question that's come in related to characterization of heterogeneity in reservoir rock properties like porosity, permeability.
I'm assuming that's in relation to Sleipner.
I would guess
reservoir.
so.
Yeah. Well, you know, every case will be different, but in the Sleipner case, we've included well logs, which have petrophysical logs like neutron porosity data, gamma logs. And Anna-Kari described the 9 layers that we can see on time-lapse seismic, but we know that there are many more layers which you can see on the well logs in the data set. So there is a lot more information than we showed in this short presentation, which includes petrophysical data down the well. Not very much core data, but some core data. And we imagine that every data set will be different, but that's the case of the Sleipner, which is actually a fairly homogeneous sandstone, where the most important thing is actually the shales. And we've put in the data set everything that we know about those shales.
Okay, and he carries on to say, will it be made available, and if so, when? But I think,
well, the data is available. Yeah, all the data I described is currently available.
Okay, perfect. Thank you.
Follow-on question to that is, I'm assuming CO2 Data Share is now fully operational and will remain so for how long? A year, or what's the envisaged timescale for its operation?
Okay, I think I can answer to that. Now we have this consortium with the CO2 Data Share project, and this project has now received funding for 3 years. So we will be working through this project until the beginning of 2021. And to be able to operate and maintain the portal beyond that, we need to develop a continuation. So that is our main focus now, to find both a funding model and also funding instruments that can allow us to continue to operate and maintain this digital portal. Yeah.
Okay, that sounds good. And I guess that's going to involve monitoring its usage and how many times it's downloaded around the world.
Yeah.
As well.
Yeah, we have some monitoring of statistics so that we can see it's based on voluntary information from the users, but we have some statistics to see how many times the different data packages are downloaded and from where and what kind of institutions. That is interesting for us to see who are accessing the data and downloading it for use. So we have some statistics on that.
One of the problems we have is that we know roughly who might be interested in funding this in the future in Norway and the United States, but we need to find organizations that will be interested in funding this in other countries. So one of the challenges we have this coming year is who would be interested in supporting this initiative. But I think if we can show that it's going to bring very significant benefits to, you could say, the process of limiting greenhouse gas emissions, then hopefully others will say, we want to join.
And part of that will be to, as it were, spread the word and make sure that there are a lot of areas, North America and Europe, where people are conversant, but I think the real power of this could be in areas, and certainly in countries where there is less familiarity within the sort of scientific, technical, and perhaps even broader community, and that people can see what is achievable.
Yeah.
Can you see that one?
We got incoming questions?
We have.
Yeah, I'm just trying to. So I'm reading that as someone asking about in the future, will there be implemented a section related to transportation characteristics and method for CO2 in CCS projects?
I think the questioner is probably referring to transportation of CO2 by pipeline and ship, perhaps?
Yes,
Could be, yeah.
that would be, yeah.
Yeah.
Compositional data, phase behavior of CO2, and all I can say is that would be great. We would love such data sets to be included. Certain of those things are in the published literature, so then the hard thing would be to find, if you like, a quantitative data set that would bring a significant benefit. So if somebody had a laboratory or field study of a pipeline, maybe they could share that data set. So we would be very open to that.
Well, that's very encouraging, because again, as CO2 transport links develop, the operational conditions, things like water content and subordinate gases in it, people are interested in that and the impact that it has. So this sort of sharing of data could be very useful. And I'm assuming that it's open access, so anybody with an interest, there's no restriction. They don't have, or maybe they do have to register. I don't know.
I mean, Odd can explain, but at the moment, the only criteria we ask for the Sleipner dataset, which is open using a Creative Commons license, is that when you download it, you accept the terms and conditions by clicking. You don't actually have to give your name. You just have to give some basic information about where you are. Is that correct, Odd?
That is correct. For the moment, we don't have a user login system, that might come in the future. Also, the organizations that contribute data they do have their page on the portal.
Good. A Sleipner specific question has come in. Will additional 4D seismic data beyond 2010 be added to the database at some stage? I guess
that will depend on what the Sleipner license decides to do with their data. So far, there are no plans for it, but who knows what the future will bring.
And I guess that opens a broader question in that with additional data sets, they will need to be added, because one would hope if it's research orientated, new data will be added. So I guess there needs to be an initiative to promote sort of not just, if you like, donation of data, but onward management and addition to it.
Yeah, we have thought about that, and obviously we can update a data set and bring in new material. That's obviously possible, but the other thing we've discussed is how the users might interact with this. Like if people download this data set and discover something interesting, how could they, report that to the community? So you could eventually have some kind of community page where people share their findings.
And something that's just come in along those lines, I'll read out. What's your thoughts about suitability of data set for studies concerning risk, uncertainty of geological carbon storage, especially, well, it says here carbon leakage. I think they're referring to CO2 leakage. Are there such studies? Would this data set be convenient to work on these of leakage concerns? And which part of the data set you would think would be interesting to look into? Now, that's a sort of, we're slightly broadening the discussion here, but it does exemplify its potential use, as Philip has just alluded to. So any thoughts about that open question?
Yeah, well, one thing I could say, James, is that we've focused on the CO2 in the reservoir unit, so you would understand how CO2 moves in the reservoir. But if you're interested in leakage, then you'd have to be speculative and say, well, what happens if? The seismic data set includes the reflection data to the surface, so you could look at leakage scenarios with this data set.
Okay.
So yeah, and in the future there may be other data sets that specifically look at leakage. For example, looking at volcanic areas where there's natural CO2 seepage could be useful. But I should say that there isn't any leakage at Sleipner, so there's nothing to study.
There's a sort of open question again. What sort of ballpark figure on funding are we sort of looking at for potential contributors in the future? Are we talking thousands of dollars or hundreds of thousands, or what's any thoughts on the sort of range of funding?
I would say that it is a range depending on the ambitions. We have made some preliminary estimates regarding what it would take to kind of operate a kind of minimum solution, just maintaining what we have and maybe adding 1 or 2 data sets. Maybe we are around $100,000 US per year could be kind of a minimum, just to keep it alive, keep it in operation. But if we want to have activity preparing and including several more data sets per year, we are at 200,000 maybe US per year or more.
Okay.
Well,
we're just about out of time now, so a few things. First of all, I'd like to thank the 4 main contributors, Greta, Odd, Philip and Anna Kari, and indeed at this end Suzanne, who makes sure everything works in the right order. I would say to everybody, we can make the slides available on request, and they will also be displayed on YouTube. please engage with us. We are very interested in expanding what CO2 Data Share can do, so I would urge you to try and use it, and then think about how you might potentially contribute to it in the future, because we do want to encourage greater international engagement and participation, because I think this is a really exciting tool. CO2 storage, CCS, is moving into quite a dynamic phase now, and I think greater international participation through initiatives like this, as well as everything else, are really exciting. So I would urge you all to engage with it. And with that, thank you very much. Oh, and please do keep an eye on our website. That is our main window on the world. And that's where the YouTube demonstration will be shown. So thank you again to everybody, and we'll close proceedings there.
Thank you.